That's meant to be a circle there. Okay, so circles are very important. Realistically, they're 100% going to come up at some point, and you will 100% need to know these next two formulas for definite that I'm about to show you. And then we'll look at this little thing here and looking at problems like that. So firstly, a bit about circles. I'm going to try and draw a big one. It'll do, to be fair. Could have been worse. So circle, pretend. No one can draw a perfect circle doesn't exist. Okay, so it's fine. This is your centre, and then we're going to do bits about a circle. Here, from the centre to the circumference there, that is the, yeah, I can hear you shouting at your computers, that is the radius, okay? From, I'm going to do it this way. Here, through here. So from one side to the other, but through the centre, this is your diameter. And as you can see, your diameter consists of two radii, I think is a plural of radius. Other things to know. This, here, like a slice of literally most foods, pizza, cake, the best foods ever. This is called a sector. And next time you want a piece of pizza or a piece of cake, just to get it into your head, be like, can I have a this sized, instead of slice, sector? And everyone will think you're a bit odd, but then they'll remember it too, so realistically you're doing everyone a favour. So what about this line here? So a line from both sides, but this one doesn't go through the centre. So this one does go through the centre, its diameter, this one doesn't. And this looks like, this, if you cannot tell, is a guitar. And it kind of looks like a chord. It looks like something to do with music. I don't know if that helps, but it might do. We have chord. Then we have something on the outside here that just touches the circle. This is called a tangent to the circle, a line that just touches. And then an area like this here, this is called a segment. And I think that is all the parts of a circle that you should need to know. And now we're going to work out work out some stuff, for example. So can you hear this sector / slice? It's the same as what we've drawn here. We're going to work out the area of sectors and stuff like that. But the key points you need to know, I think, are, the circumference is all the way around. You want circumference, radius. You need to know all these parts of a circle. Diameter, sector, chord, tangent, and segment. I think they're the ones you need to be able to recognise. May have missed one. Anyway, let's go on to area. This is kind of the big, well, it's not really a big formula, but it comes up a lot, and it's kind of one you should know. So area of a circle is pi r squared, and the r stands for the radius in this list. And in the revision guide it says pi's r squared, not round, so really doesn't really make sense. But try and maybe think of this as pies, as in pies you eat, even though it's spelled differently. Try and a pi being square. How is this a pie? Honestly, I don't know. This is my pastry. Try and think of, no, gotta rub that out, that's ridiculous. Try and think of just visualise a square pie, and then that's the area of a circle. So pi r squared. Pi is r squared. Okay, so let's do an example. Circle here. I'm going to say that's 3 centimetres there. So the area of that circle, use the formula pi r squared. Pi is pi times radius 3 squared. So that's 9 pi. There we go. Nice and simple. Other one is circumference. If only there was a B, then it would like be the alphabet ABC, but it's not. This one is pi d, also known as pi 2r, because d is the diameter, which, as we saw from the diagram, is 2 times the radius. So when I'm thinking of area, so that is working out the area of here. Circumference, this is working out how long the length all around the outside of a circle. And I'm going to put that as, even though it looks exactly the same size, not exactly, so that's 8 meters. So let's work out the circumference of this circle. So it's pi times the diameter. So pi times, and the diameter, that's the radius. So the diameter then would be, so this bit here is 8 times 2. So we're using the 2r here, times 16, pi by 16, ooh, centimeters squared, oops. And that one's meters. Okay, so I hope those examples mean that it makes sense. So you've just got to be careful with if it's giving you the radius, if it's giving you the diameter, basically. That's the only thing they can really do to trick you up there. Let's look at, ooh, I forgot something in our definitions list. Let's add it here. Arc length. So an arc length is like this, the length of that there, so oh dear, that circle. So arc length is like a little bit of the circumference that we've just worked out. And then I'm also going to draw the sector out, so I'm just going to do a sector here. Right, pretend that goes into the middle. Now we're going to be able to work out these two things, and it's actually not, I'll write them here, arc. It's actually not too bad because it's so related to area and circumference. So, as you can see here, this is an area, and we know the area of a circle is pi r squared, but we don't have a full circle. We only have sorry, I'm just doing the drawing. We only have a bit of a circle, like a slice, the sector. So the area of a sector is the area of the full circle multiplied by a fraction, because we only want a fraction of that circle. And the fraction we do is x, this angle here, over 360. So it's kind of like the fraction of this part here. So I hope that makes sense. And the way we do this one is so similar as well. So this is a length. So if we look at the circumference, is pi d, but we don't have the whole circumference. We have a fraction of the circumference. We immediately think fraction. Again, 360. And it's this angle here over 360. Okay, so you've got the area, but you've got a fraction of it, and you've got the length, but you've got a fraction of it. Sector is x over 360 times pi r squared, and arc length is the fraction, which is that of the circumference, which is that. Okay, let's look at some examples. I'm going to draw a slice of, that's going to be carrot cake today, even though you can't tell. I feel like it should be carrot cake. That's 30 degrees, and that there is 4 centimetres, the radius there. And I want the area of this sector, slice or sector. So I know that the formula is literally written there, so I can just copy it off. But if that wasn't there, I can think through it logically, and I want the area of this. So first of all, I could get the area of the whole circle. So if I get the area of the whole circle, that would be pi times r squared, which is pi times 4 squared, which is 16 pi centimetres squared. But that, if I draw it out, I've got all of that, which is kind of a bit much. That wasn't what I was asked for. I didn't want all of that. I just want a bit. I don't want that much carrot cake. So I want that much. So I'm thinking, oh, I've got a fraction of that. And it kind of makes sense as I say it. I think fraction. Okay. And we know the fraction from here, but let's pretend we didn't. We're just trying to think it through logically. Is that angle in the middle there? 30 over 360 times the pi r squared. But we've already done that bit. 16 pi. And I'm going to get my calculator to work this one out. 4 over 3 pi, I hope that's correct, centimetres squared. Okay, so it does kind of make logical sense. You can either just remember the formula, write it down, plonk it in, but if you can't, you can just think it through by thinking, oh, I've got an area of a circle, a bit of a circle, so I'll find the area of the full circle, and then get a fraction of it. Okay, what about if I want the arc length? So I want this. And I'm given this information. Okay, I think, that's not the circumference. I like the circumference. I know what to do with the circumference. But I think, I guess it's a bit of the circumference. So either I can just copy this formula down and put in the x and the d, or I can think through it and think, right, first, if I get the circumference of the whole circle, I know that that is pi times d, which in this case is pi times, and then careful, that's the radius, and I want the diameter, so the diameter is double the radius, so 5 times 2. So that's 10 pi metres, but then I think, oh, that was the full circle, I don't want the full circle, I want a fraction of it, and that fraction of it is this fraction here, 40 divided by 360 times the pi d, which we've already got, the fraction of that, and whatever that answer is, meters. So that would be the arc length. So you can either just remember the formula, plug it straight in, or think it through that way. I'm going to do another question, and there we go. That is meant to be a semicircle. I want the area of the semicircle. And we know that semicircle is half a circle. So first step, let's work out the area of the full circle, which we know from the formula, that pi's are not squared. Pi's are squared, even though they're not. So pi r squared, anyway. So pi, let's plug that in. What's this? That is the diameter. We don't want the diameter, we want the radius, we want half of it. We want this bit. So that's 2. Pi r squared, so that's pi times 4. So that's 4 pi centimetres squared. That's the area of the full circle, but I don't have the full circle. I want the area of this, that's what I'm looking for. And so, as we know, semicircle, half circle, so half the area, so we've got, getting ahead of myself, 4 pi divided by 2 pi centimetres squared. So that's an example if they give you a semicircular one, and also the fact that they will mix up giving you the radius and diameter on purpose. So just get that nice extra mark. You just got to be so ahead of the game, you're kind of waiting for them to do it. You're sort of just looking at the question like, I know that you're going to give me a radius when I need a diameter. Anyway, now I'm going to look at this object here, candle. It honestly smells great. It's Yankee red raspberries. I really recommend. And I want to work out the area of that circle there. I could draw it around it. I'm not going to draw around it. Yes, I am. Oh dear. I'm not going to draw around it very well. So I'm looking for this area here, and I know the formula is pi times r squared. Pi's are squared. No, they're not, but they are, but they're not. What? Okay, so I'm going to measure that. Diameter, so I've kind of got to go through the centre. This obviously is not perfect, but that is 4 centimetres. So that was 4 pi, but I don't want 4, I want the radius bit, so I can measure from there. 2 centimetres squared, so 4 pi centimetres squared is the area of that face there. Okay.